Hello everyone, my name is Srinidhi. I am currently pursuing BE in Computer Science Engineering at Kongonadu College of Engineering and Technology. I am going to share my views on CPU scheduling. Let us see one by one. First, we'll see what is CPU scheduling. CPU scheduling is the process of determining which process in the ready queue gets to execute next on the CPU. It ensures that CPU is utilized efficiently by switching between processes based on the scheduling algorithm. Next is the why is CPU scheduling important? It maximizes CPU utilization, that is, it ensures the CPU is always busy, improves system performance, it reduces the waiting time and increases the response time. Next, it manages multiple processes. It helps multitasking and efficient execution of the process. Prevents starvation, ensures all processes get a chance to execute. And next we'll see about types of CPU scheduling. It has two types. It is preemptive scheduling and non-preemptive scheduling. The preemptive scheduling, the CPU can be taken away from a process if high priority process arrives. It is if the higher priority process arrives, then it will first see higher priority process only. And next is the non-preemptive scheduling. Once a process starts execution, it rests until completion before switching. It doesn't see higher priority process or lower priority process. It only see if one process runs at a time. After completion of it only, it focuses on the other part. Next is the diagrammatic view of the CPU scheduling and the algorithms in it. And next it is a comparison. We have algorithms. FCFS means first come first search, SGF short job first, RR round robin, and priority scheduling. Here preemptive means no, FCFS is not a preemptive. SGF it is a both preemptive as well as non-preemptive. RR round robin is a preemptive. Priority scheduling is both preemptive and non-preemptive. Here average waiting time for the FCFS is high, whereas in SGF it is low or optimal, and RR it is medium, and priority it is varies based on that. Here starvation means FCFS has no starvation and RR has no starvation, whereas SJF and priority has a starvation. And next is CPU scheduling criteria. CPU scheduling criteria denotes with CPU utilization, throughput, turnaround time, waiting time, response time, fairness. Here the utilization includes maximum CPU usage which is high, and throughput is increased completed task which is also high. Turnaround time minimize the execution time, it is critical. Waiting time, it reduces the queue time, it is very important. Response time, it improves the interactivity which is critical. Fairness prevents starvation among, and it is necessary. And now let us see which algorithm is best. Here are the three: round robin, short job first, priority scheduling. Round robin is good for response but high overhead. Short job first is optimal for low waiting time but causes the starvation. Priority scheduling, it is useful when some tasks are more urgent. Next is the CPU utilization. It measures how efficiently the CPU is being used. Its goal is to keep the CPU as busy as possible. It typically ranges from 40% to the 90%. Next is throughput, the number of processes completed per unit time. If the throughput in the process is high, it has a better performance. And next is the turnaround time, which is known as TAT. The total time taken for a process from submission to completion is known as turnaround time. The formula for turnaround time is TAT is equal to completion time minus arrival time. If the process has the lower turnaround time, it's better to ensure faster execution. Next is the waiting time, the total time a process spends waiting in the ready queue. If the process needs to be processed and it spends the whole time in waiting in the queue is known as waiting time. Its formula is turnaround time minus burst time. Lower waiting time improves system response. Lower waiting time improves the response of the system. Next is the response time. As we see in the previous slide, that lower waiting time improves system responsiveness. Here we note response time. The time taken for the CPU to respond after a process which arrives in the ready queue. It is important in interactive systems where the immediate feedback is required. Fairness. Fairness denotes it ensures the no process tabs waiting indefinitely due to low priority. It prevents some process from getting too much or too late from the CPU. And next is the contact switching. Contact switching is the process of saving the state of one process and loading the state of another. It allows multitasking by switching between the process efficiently. It happens when CPU switches from one process to another due to scheduling decisions. And the next is steps involved in contact switching. First, we want to save the current process state, that is for registers, program counter, etc. And next, move the process to the ready queue if it is not finished. If the process is not yet completed, it should wait in the ready queue for completion of that project after the completion of the previous project. Next, load the new process state from the PCB. PCB is known as process control board. And fourth is the resume execution of the new process. And next, other topics related to CPU scheduling. First, process scheduling. Process scheduling deals with how the OS manages process at different stages, that is new, ready, running, waiting, etc. etc. Next, thread scheduling. Scheduling techniques for multi-threading in modern CPUs is known as thread scheduling. Next, as we see in the previous slides, contact switching. How the CPU switches from one process to another. And next, multi-level queue scheduling. Multi-level queue scheduling is a special scheduling method which is used in the real-world OS implementations. Next, deadlock in OS. When multiple processes block each other preventing process, it leads to deadlock conditions. So that is known as deadlock in OS. And next, input-output scheduling. Input-output scheduling is the how the OS prioritize discrete write operations is known as the I input-output scheduling. That is known as IO scheduling also. And next, as we see in the previous slide, which algorithm is best? As for the same things, we will say round robin, shortest job first, priority scheduling. And that's it. Thank you so much.